Hi, I'm Bob. Welcome back to 5 Minute Econometrics. In the previous topic, we discussed the first data problem we often encounter in the econometric analysis. It is the sample selection due to missing data. Today, we will explore the second data issue, outliers and inferential observations in a sample. An outlier or inferential observation is the observation that can change the OLS estimates substantially when added to or dropped off the model. We are concerned about the outliers because we could have different conclusions with or without that observation in the sample. Outliers or inferential observations can arise from two main sources: errors in data collection and sampling from a small population that includes a member significantly different from the rest. When outliers are due to mistakes in data entry, they should be removed. However, for a maverick or unusual observation within a population, deciding whether to keep or drop it can be challenging. The reasons for the existence of outliers are not always immediately clear. Therefore, it is a good idea to report results both with and without the outliers. In Stata, we can use the summarize command to find information about variables. It tells us potential outliers. Here's an example. The sample contains data on 32 firms' R&D expenditures as a percentage of sales, annual sales, and profits as a percentage of sales. We want to know whether the firm's size is positively related to the firm's R&D intensity. In Stata, we type summarize with the detail option to find the minimum and maximum values of a variable in the sample, along with the variables sample mean and median. We find that the largest firm has annual sales more than double those of the second largest firm and more than 10 times the sample average. The largest firm is an outlier in this sample. We can also plot the observations in a graph with the outcome variable on the y-axis and the key explanatory variable on the x-axis. The plots can help identify the possible outliers. The scatter command is for the graph in Stata. The graph confirms the largest firm is an outlier. It is advisable to report the OLS estimates with and without the outlier. With the outlier, the OLS estimate for the firm size is not statistically significant at any conventional level. However, without that outlier, the OLS estimate increases by more than twice in size and becomes statistically significant at the 5% level. Firm size is positively associated with its R&D intensity. The sample above demonstrates that ordinary least squares OLS estimators are sensitive to outliers. The OLS method minimizes the sum of squared residuals, meaning that outliers have disproportionate weight on the estimates. As a result, the outliers can significantly distort the OLS estimates. In addition, the R-squared from the model without the outlier is much higher than that with the outlier. We see that the fitted line without the outlier has a steeper slope and fits the data better. The logarithmic functional form can help reduce the outlier's influence on the OLS estimates. If we use the logarithm of the outcome and the key explanatory variable, the difference in the OLS estimates between the outlier and the non-outlier cases will be much smaller. Today, we discuss the outliers or the inferential observations in a sample. We usually drop the outliers if it is a obvious mistake. However, it's not always clear whether it is an error in data collection. So it's a good idea to report the OLS estimates with and without the outliers. Or we can use the logarithmic functional form to reduce the influence of the outliers on the OLS estimates. Another way to deal with outliers is the least absolute deviations estimation method. It is much less sensitive to outliers than the OLS method. We have already talked about the LAD method in previous videos. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.